So we're going to go over lesson 5.3, exponential functions. And our objectives are to evaluate exponential functions, graph them, graph exponential functions to find the number e, and solve exponential equations. So basically, we're going to take a look at calculator use real quick. So
This is 5.3.
yes, this is lesson 5.3.
Okay, and you'll be able to post this video after on Blackboard after
Yeah,
we get done. Okay.
yeah, it may not be today, but I'll get. It takes time to process, both on my, because it processes directly to my laptop, and then so it takes time to process on my laptop, and then it takes time to process it. I copy it to Zoom, to YouTube on my YouTube channel, and it takes time to. I have to edit it, and it takes time to process that video too. So it'll be a little while.
Okay.
But we want to take a look at calculator use. Usage. So if we looked at something like 3 to the 1.7 power. Okay, if we go to the calculator, we put in 3. I'll turn it on. Put in 3, and then the exponent button for rooftop looking exponent button, and then 1.7, and you get your number. And then you just round it off to however many decimal places the problem tells you to round it off to. All right. Let's see. I'll let Morgan in. Zay Morgan. Morning, Zay. We're just getting started. We're working on lesson 5.3, exponential functions. Okay, so the rest of them are basically the same thing as far as applying the calculator. All right, so let's go back to our PowerPoint. So here we are, 5.3 exponential functions. Okay, so let's look at the laws of exponents. Okay, we said before, we've said in the past that when we multiply bases, we add the exponents. And so let's see what that looks like as a review example. And these properties of exponents. Okay, so we said before that if we have a to the s times a to the t, for example, then we would just add the exponents. For example, if we had x to the 7th times x to the 5th, that would be x to the 7 plus 5, and so that would be x to the 12th. All right, if we have another property of exponents is if we have a to the s parentheses and then parentheses t, here we're going to multiply the exponents. So if we had x to the 7th parentheses 5th, that'd be x to the 7 times 5, or x to the 35th power. 1 to any power is still just 1. If we have a to the negative n power, then that you apply the reciprocal 1 over a to the n. So if we had, let's say, 2 to the negative 3 power, then that would be 1 over 2 to the 3rd, or 1 over 8. And anything to the 0 power is 1. So if we had 1,000,000 to the 0 power, that's still 1. All right. So that's the property of exponents there. Any questions with the properties of exponents? All right. Okay.
No, sir.
Exponential functions. That's where we have the unknown. X is up as an exponent. So far, up to this point, we've always had x down here at the base, like where a is. But when the unknown, the variable, is up as an exponent, then that's known as the exponential function. C is known as the initial value, so that if x is 0, like at the y-axis, the y-intercept, then that's where the function starts. Normally, the function will intercept the y-axis at 1 when x is 0, y is 1. But if you have this c value here, then it's whatever that c value is. So if we have, for example, let's say we have a y equals 2 to the x power. Well, at 0, when x is 0, right, like 2 to the 0 power, that's 1. Anything where the exponent is negative, it's going to get smaller and smaller and smaller. When x is 1, the y value is going to be whatever the base is. So as this base gets larger, that's going to make the graph get steeper. Well, if we had y equals to, let's say, 3 times 2 to the x power, now instead of starting at 1, now this is going to start at 1, 2, 3. Like that. But we're not going to do too much with those kind of exponents. All right. So continuing on with our PowerPoint notes. An exponential function, this is a example of the number of cell phone subscribers at the end of a year from 1985 to 2008. And it starts off, not many cell phone users in 1985, in the 80s. But it really starts to take off in the 90s, and after Y2K, year 2000, it really starts to take off and grows at an exponential rate, so that each year the growth accelerates. So this is known as an exponential, this is known as growing at an exponential rate. Okay, so here's another graph of exponential functions, and what I was talking about. Here, this is in black, y equals 3 to the x power. Well, notice when x is 0, y is 1. And then if x is negative 1, then it's 3 to the negative 1 power, or 1/3. So it gets smaller as it becomes more negative, it gets smaller and smaller and smaller. But as it gets, once it passes the y-axis, then it starts to grow larger. So that at the base, 3, it's 1/3. Well, if you look at y equals 6 to the x power, that's when x is 1, y is 6. So that's at 1/6. So you can see that the higher the base is, the steeper the graph gets. All right? So that's the power of exponential functions. All right. So that's all we're going to work with graphs for right now. So let's look at the number e. Well, what exactly is e? Well, e is a e is used in finance and also in science. E is known as growing. It's compounding continuously for compound interest. And so it's 1 plus 1 over n to the n power, where n continues on through infinity. So if you continue on, you get this number becomes 2.71. So if you look on your calculator, all right, let's take a look at how that looks on the calculator. So on the calculator, you have right here above natural log, you have e to the x power. So if you hit second and e to the x, okay, you get that. And then if you put 1 in there, you get what e is as a number. It rounds off to 2.72, but it's irrational, like pi is irrational. It goes on forever and there's no pattern to it. But a lot of times we round it off to 2.72. Okay, so that's e. So why do we use e? Well, e is used where things are growing continuously, or compounded continuously. Like in finance, you'll have compounded yearly, compounded quarterly, where the interest is compounded, every 3 months, compounded monthly, where the interest is compounded every month, compounded daily, compounded hourly, so, and then after that is E, where E is considered compounded continuously. Well, it comes out to that if we break it down, there's, like every so many minutes, e is compounded. So e is considered something that's compounded at a continual basis. And e can be used in science, like in populations, for example, where populations grow, especially like bacteria, where it grows at a rapid rate, then we use e. Okay, so consider e. So we look at y equals to e to the x power. E, consider e just another base, like 2.72 to the x power. So don't let e throw you. E is really nothing more than rounded off to 2.72. Okay, so if we were to look at it on a graph, and this were to, it's still going to go through at 1, but here at 1, this will be 1, x is 1, y is 2.7, rounded off to 2.72 as an ordered pair. Okay, so just think of e as another number. Okay, now let's take a look at some properties of exponents. Now, if whenever this, if the video, the lesson gets cut off short, we'll just re-enter on the same link. Okay, if in solving exponential problems, we use the property of exponents where we say if we have some base to a certain power equals to another base which is the same but a different power, if a to the u equals a to the v, then we set the exponents equal to each other. Well, what does that really mean? Well, if in solving exponential problems, if you had, let's say, 2 to the x power equals to 8. If we can get these to be the same base, then we can figure out what x is. Well, 8 is really 2 to the third power. So here we have 2 to the x equal 2 to the third. So the base on the left is the same as the base on the right. So that means we can set the exponents equal to each other. So therefore, x equals 3. And that's our answer. And you can substitute 3 back in. That equals 8, and it checks. Okay, so let's say we have 5 to the x power equals to 25. So we ask ourselves, all right, 25 is 5 to what power? Well, 25 is 5 to the second, right? So we put 5 to the second, 5 to the x equals to 5 to the second. So we set the exponents equal to each other, and our answer is x equals 2. Okay, let's try another one. Let's say that we have 4 to the negative x equals to 1 over 64. We have a fraction. So basically what we do is we use the property of exponents of x to the negative n equals to 1 over, we use the property of negative exponents. Only this time we're going to work backwards. We're going to go from a fraction to a negative exponent. So this 64 becomes, 1 over 64 becomes 64 to the negative 1 power. And so we make this 4 to the negative x. So we ask ourselves, 64 is 4 to what power? Well, 4 times 2 is 16, right? So 4 times 3 is 64, but you have a negative 1, so it's negative 1 times 3 equals 4 to the negative x power. So this will be 4 to the negative x equals 4 to the negative 1 times 3 is negative 3 power. So that means we can set the exponents equal to each other. And from here, we can go ahead and divide by negative 1. Divide by negative 1. Negative divided by negative is positive. Negative divided by negative is positive. And we get x equal to 3. And that's our answer. Okay, any questions with that? Excuse me. All right, let's say that we have something like this, where we have 5, and then parentheses 7 minus 2x equals 5. So basically, this 7 minus 2x is an exponent. It's superscript or raised up. Well, there's no exponent here, right? But anything that we can always imply that this is 5 to the first power. So our base on the left is the same as our base on the right. So we have a to the u equals a to the v. So we set the exponents. Since the bases are the same on both sides, we can set the exponents equal to each other. So therefore, we can set 7 minus 2x equals to 1. And then solve for x. So from here, we would apply minus 7 to both sides. And we get negative 2x equal to a negative 1 minus 7 is a negative 6. And then we divide by negative 2. Divide by negative 2. And negative divided by negative is a positive. 2 divided by 2 is 1. We get 1x. Again, negative 6 divided by negative 2 becomes a positive 3. So our answer is 3. Well, if we checked it by substituting 3 back in, right? 5 to the 7 minus 2 times 3, we should get 5. Excuse me. So 2 times 3 is 6. Let's see if that works. So 7 minus 6, yep. That's going to be 5 to the first, which is 5, and it checks. Any questions there? Okay. Let's look at another one. Let's say that we have 2 to the 3x minus 1 equals to 32. Well, we want to see if we can apply a to the u equals a. If the bases are the same, then we can set the exponents equal to each other. So if we can get 32 to be 2 to some power, right, then we can use the property of exponents. Well, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So that would make this 2 to the 5th, right? So that we would set 2 to the 3x minus 1 equals to 2 to the 5th. So since the base on the left is the same as the base on the right, we can say, all right, we can apply properties of exponents. So we can go ahead and set 3x minus 1 equals to 5. And then solve for x. Apply plus 1 to both sides. And we get 3x equal to 6. And then divide by 3. Divide by 3, divide by 3. And we get x equal to 2. So we should go back and be able to substitute 2 in to our original equation. And if we get 32, then it checks. Well, let's see if we do. So this would be 2 to the 3 times 2 minus 1 power. 3 times 2 is 6. So 2 to the 6 minus 1 is equal to 2 to the 5th. Well, 2 to the 5th does, in fact, equal to 32. So both sides check. It checks out. All right. Any questions with that?
No, sir.
All righty. Now here, let's try one with e in it. Here we have e to the 2x minus 1 equals to 1 over e to the 3x times e to the negative x to the 4th power. Okay, so remember now, e, just think of e as like 2.7. Okay, so we look at properties of exponents. So we need to simplify the right side. Well, we said before that when we have an exponent to an exponent, we multiply, right? So that's going to be 1 over e to the 3x times e to the negative, this will be 4 times x, right? Or negative 4x. And so the left side, that doesn't change yet. That's still 2x minus e to the 2x minus 1. So here on the right side, that's the same thing as if we said e to the negative 4x over e to the 3x. Well, x to the m over x to the n. If we looked at properties of exponents, right, and we're dividing, we subtract x to the m minus n. We're subtracting. If we're dividing the bases, we subtract. So this is still e to the 2x minus 1. So this would be e to the negative 4x minus 3x equals to e to the 2x minus 1. So negative 4x minus 3x is e to the negative 7x and e to the 2x minus 1. Well, the base on our left is the same as our base on the right. Just think of that as 2.7. 2.7 for our base. So we can set our exponents equal to each other. So that'll be 2x minus 1 equals to negative 7x. Okay, so now if we apply the negative 2x to both sides, minus 2x minus 2x, 2x's, they go to 0, right? So you get a negative 1 equals to a negative 9x. Let's move this up here. So negative 1 equals to negative 9x. All I'm doing is just moving this up. Now if we divide by negative 9, divide by negative 9, divide by negative 9, negative divided by negative is positive. 9 on a 9, that's 1. Negative divided by negative is a positive. We get 1 over 9. And 1 over 9 is our answer. Okay, questions there?
No, sir.
All right. So if we get cut off, well, we only got 5 minutes. If we get cut off, we'll just end it here, and then we'll continue with this on Wednesday. But really, I only have one more problem anyways. So we have 9 to the 2x minus 5 equals to 27x. Well, we're not going to get anything to some power to give us 9. But we can change both of these to 3. Well, 3 to what power is 9? 3 to the second, right? So this will be 3 to the second, and then we're going to put in parentheses 2x minus 5. Well, 3 to what power is 27? Well, 3 times 3 is 9. Yeah, 3, right? Times 3 is 27. So 3x, right? So now we have our base on the left is the same as our base on the right. And so now we can set this as 2 times 2x minus 5 equal to 3x. And we distribute. 2 times 2x is 4x. 2 times 5 is 10 equal to 3x. And then we just apply minus 4x to both sides. Minus 4x. And we get negative 10 equal to a negative 1x. And then divide by negative 1 to both sides. And we get x equal 10. And that's our answer. So if we checked it, plugged in 10 here, right? 9 to the 2 times 10 minus 5 equals to 27 to the 10th power. Then you can check that on the calculator, right? 2 times 10 is 20, minus 5 is 9 to the 15th equals to 27 to the 10th. Well, we can check that on the calculator, right? 9 to the 15th. We get 2 times 10 to the 14th. So that's the same thing as if we said 2 times 10 to the 14th power. So that's what that E is in scientific notation. So if we took 27 to the 10th power, we should get the same number. And we do. So it checks. Okay, so we know it's a good answer because we checked it. All right. And any questions with that?
No, sir.
Okay, that is 5.3.